Good afternoon everyone, I'm Steven and this is my team Isa and Niti, and today we are going to present our simulation product called SIN3 Virus Management. Okay, so here is our agenda for today. We will explain about SIN3 and why we need SIN3. Next, we will go through our model and the verbal event graphs. Lastly, we will explain about the tutorial and the pricing strategy. What is SIN3? SIN3 is a simulation product which do simulation for workers in IT department for a company to get the optimal numbers of employees need to be hired for virus management. SIN3 is very universal. You can adapt many organizational structures from small company to big company. SIN3 is very simple, it is very user-friendly, and it is flexible. The user can adjust the input based on their data. Next, I will pass to Isa for explain who needs SIN3.
Everyone needs SIN3, but we're geared towards small and medium enterprises because we offer information on vital employee statistics. Also, we make your IT department more efficient, reducing waste and cutting cost. Also, if you really care about the durability and longevity of your company when it comes to virus management, you need SIN3. Today's entrepreneur runs a website. There are almost 5,000 websites started every day that are just backed by venture capitalists. This graph does not include those that are funded by any other means. However, internet sources cite that 90% of these companies fail within the first 120 days. There's an immediate need for SIN3. Not only can a mismanaged virus cost you time and money, it can also lead to the eventual failure of your company. With SIN3 at conception of the company, you can reduce employee downtime, prepare for scalability, monitor company growth, increase employee efficiency. You can do so much with SIN3 because it is a tool as integral to your company as Word or Excel, and its implementation is essentially as great as your company is.
We have three main parts for our model. First is that if the virus is unidentifiable or the employee couldn't fix it, it will be sent to the third party. Second is the virus fixing part. After the virus is fixed, the virus will undergo the quality assurance process, which determines if the virus has to be refixed or not. Otherwise, it will just leave our system. Next, I will be talking about our model assumptions. First is that we have three classes of virus and employees, in which each employee could work on only one virus at a time. Also, it could work on only the corresponding type of virus. Lastly, there is 10% chance that the virus needs to be refixed. So here's our differences between classes and priorities. Classes is determined by the user input. The priority is determined by the frequency of the virus arrival, which is also the user input. So the more frequent the virus comes to our system, the more priority it has.
Okay, so here is our interface will look like. We have three parts: company information, virus information, and virus policy. So first, you need to fill in the company information. Click employee button, and then this form will appear, and you need to fill in how many employees are working on each class of virus. Once you finish filling the employees' numbers, click back to menu, and then you fill the virus information. Click occurrence button, and then fill in the percentage of virus falls into each class category. Also, you need to fill in the percentage of unidentifiable virus. Next, you fill the length of run in terms of days. Once you finish, click back to menu, and then fill in the fixing information. So here is, in the fixing information, you need to fill in how many times it takes for the employees to fix the virus from each class of virus. So there are maximum time and minimum time that you need to fill. Once you finish, click back to menu, and then fill in the virus policy. Click priority button, and then fill in how many times or how frequent in a certain period that the virus arrives into the system. Once you finish, click back to menu, and then run the program. Click simulate button, and then when you want to see the output trace, click that button, see output trace button, and when you want to see the output graphs, click the next one, see output graphs. Next, here is our sample traces. Actually, we can determine the amount of employees need to be hired from each class of virus. Next, we have the graph for the queues, number of queues of virus waiting in a line versus the time. The time is the length of runs actually. So we see that when we have 3 employees, the queue of virus is long actually. It means virus need to wait long in the system. However, next we have the 6 employees. The number of queues waiting is not that long actually. So it's bumping around between 0 and 3.